Hi class, welcome to another lecture on CS575. This time we will see the higher order autoregressive models. So in the previous class we saw AR1 and MA1 process. Now this time we are defining a higher order autoregressive. So higher order autoregressive says that a pth order, right? So pth order AR model. So if we have AR of the pth order. So in terms of ARIMA, how will it write? We will write it ARI. Since we are having only the AR model, we will have it pth order, zero differencing and zero MA component. This makes it the ARP model. So as you saw in the previous class, we defined YT in terms of beta naught and the error term plus the intermediate lags T minus 1, T minus 2 up to T minus P, and they also use this corresponding notations. I am showing both the notations because some text may have a different notation. So C can be equated to beta naught, ET can be equated to this ET, right? So since we are having the pth order, we are having P terms here, right? And when you had the AR1 model in the previous case, we had this term, and this particular term, right? Because it was AR1, we consider only one lag value. If we have two AR terms, then we consider two lag. If we have PAR terms, ARP model, then we are having P terms, right? So psi j is basically the jth autoregulation parameter we saw in the previous case also. So this is just a higher order autoregressive model. So for example, for AR1, we assume that as we already saw, this value should be between -1 to +1, because if it is exactly -1 or exactly +1, it reduces to a random walk or a white noise. Similarly, if we have second order AR function, then these are the conditions which are defined for the values of psi, right? And for higher orders, they don't define. Usually AR2 model suffices in most of the cases, but again, for higher orders, you can have such more complex equations. Then higher order autoregressive. A great variety of time series are possible with autoregressive, right? AR2 is enough because if you see AR models are very intuitive. My current value definitely depends on the previous values that I have encountered, right? So note that for AR2 models, the autocorrelation die out in damped sine wave patterns, right? So let us see one of the slide. There are two exactly significant partial autocorrelation. As I said, for AR, the parameter representation is P, so you focus on the partial autocorrelation. Let us see in the next slide. So as you can see, definitely this data is not stationary. The mean is, you can say it to some extent, but there is a trend in the starting point. So let us see what the AR2 basically shows, right? So you can see the autocorrelation is decaying here exponentially, but there is a slight increase here, right? So it says a damped sine wave, and again you can see we have a partial autocorrelation for a AR2 data, right? So although in this particular figure we have only one significant line here in the partial autocorrelation, technically it should have been another line, but let us see. Okay, so there is some issue with the plot, or else AR2 should had something like of this sort, right? So this will be a AR2 model, AR2 series data, right? If we have only one significant thing, then it reduces to a AR1 model. So would be a slight correction, I guess, here. Then higher order moving averages. As you saw in the moving averages, we initially saw this form. This is another form which is being used. But how do you identify a moving average model? You see it is just a summation of error terms, right? So initially we saw these constants B naught and ET. You can equate them together in this form. ET is here and B naught can be taken as C, right? And these are the coefficients theta1, theta2 up to theta q, right? So this is a general representation of MA models. Now basically we have here Q terms, right? So this becomes a MA of order Q. Why Q? Because we use P for AR, D for differencing, and Q for the MA model. Similar restrictions, if we have this is MA1 and this is MA2. For higher orders, we have a similar values restriction, right? So higher order moving average models, a variety of time series can be produced using moving average. In general, the autocorrelation of MAQ models are 0 beyond a lag of Q. For Q greater than 2, the PACF can show exponential delay or damped sine wave pattern, similarly that we saw in the case of higher order AR models. So these was just higher orders, but in practice, usually we see that an order of 2 or 3 are usually sufficient when dealing with the time series data, because in normal cases, beyond second or third order differencing, the series actually becomes stationary in most of the cases. So guys, that's it for this lecture. Next lecture, we will see a combination of AR and MA models.